Continuing with section 2.1a, so we are now looking at example 2, where we have another function given and we have to evaluate. The name of the function now is h, and x is the independent variable. So we do the same thing as we have been doing before. So h of -1, so we read it as h of -1, and what we do is basically in the function, wherever you see x, you are going to replace it by -1. So we get square root of -1 plus 3 divided by -1 minus 1, which is equal to, now simplify, and we get square root of 2 in the numerator. In the denominator we have -2. Now whenever you have a negative sign in the denominator but not in the numerator, the negative sign should be written up in front of the whole fraction like this. And you just leave it like that unless the question says that rationalize the function or something. And usually if we have the square root in the denominator, usually then we rationalize, and so that we get rid of the square root from the denominator. But here the square root is in the numerator, so we will leave the answer in that form. Next is h of 0, same thing, plug in 0 for x and you see we end up getting this quantity here. Again, now the negative sign is in the denominator, so we should put it up in the front. So we get negative square root of 3, the whole thing divided by by 1. But 1, we don't leave the answer in that form. So we should now say it is equal to negative square root of 3. The next one is h of 1. When I plug in 1 for x, you notice that we get 0 in the denominator. So which means now but in the numerator we have a number. So we just say nan, not a number. Okay. So now the next is h of a, which is just that you replace the x by a and you are done. Next is h of x minus 2. So again, now wherever you have x, you will replace it by x minus 2. So x replaced by x minus 2 here, and plus 3, which was already there, and divided by x minus 2 in place of x, and -1. So simplify and we end up getting this result. Next is h of a square minus 2. So same thing, plug in for x, what? A square minus 2. Wherever you had x, it will be replaced by a square minus 2. And whatever else is there, that will just remain, and then we simplify. So in the top I am getting square root of a square plus 1, and in the whole thing square under the square root, and whole divided by a square minus 3. So we'll leave the answer like that. Now note that a square plus 1 is not equal to a plus 1. Okay, the square roots do not distribute over addition. So we'll leave the answer in the form that we have. Okay, next is the piecewise function. So I already mentioned the piecewise function in the last lecture. So a piecewise function, or a piecewise defined function, or just a piecewise function, is a function that is defined by different formulas on different regions of the number line. So normally when you are asked to graph the function or evaluate the function, normally we have just one function. But in the case of piecewise function, we however many pieces of the number line we have, as many functions you will have. So in the next example 3, we see a piecewise function given by the name g of x, So we have three functions and we have three regions. So these are called the regions of the line. And you can notice that this is how it's going. This is the number line. And so we have 0 somewhere, and let's say 2 over here. So can you see when I put those numbers here, the number line has been divided into three pieces. So over in this piece, the function which we will be dealing with is 3x. Between 0 and 2, the function will be x plus 1. And from x 2 to infinity in the third region, our function is x minus 2 whole squared. So when we have to find these values, okay, so when we have to find g of -1, our first step will be to figure out where the -5 is, in which region. Okay, so g of -5 equals, so you can see -5 will be in the first region over here. So the function that we will use is 3x. We will not put here 3x, but we will just say 3 times -5, which is equal to -15. Next is g of 0. So g of 0. So we notice that 0 is kind of the critical point or end point of the region. So it is going to be kind of in both, could be considered in both, but cannot be. So because if you notice here, we see 0 written here and we see 0 written there in the second region as well. But because the equal to sign is only in one place here, so it means 0 is in the second region or in the middle region. It is not included in the first region, this one, but it is included in the second region. So we will use that second formula, and our answer is 1. Okay, the next one is g of 1. So you can see 1 is between 0 and 2. So again, we will use the same formula for evaluating g of 1. It will be 1 plus 1, which is equal to 2. Next is g of 2. Okay, so where is 2? 2 is in the region. Notice again, the 2 is, you can see 2 in 2, like written with 2 in two places, but where is the equal to sign? The equal to sign is in the second region. So we will use the second region to evaluate the 2. So it will be 2 plus 1, which is equal to 3. The last one, g of 5. Remember, this is how we evaluate the piecewise function, that first thing you do is your x value, you have to figure out where, in which region the x value lies, and then you have to pick the function accordingly. So g of 5 will be parentheses 5 minus 2 whole squared which means 3 squared, which means 9. Okay, so here is a warning, and this is a common mistake which students might do, that they, and so this has been written here as a warning to say this is not the correct way of evaluating a piecewise function. What I mean is that you do not pick your 1 or the x value and plug it in each piece, okay, in each function given, because these functions are for different regions. So you have to figure out what is your region, where is your x lying, and accordingly pick your function. Okay, because what is happening here, for one x value we are getting 3 y values, which does not satisfy the definition of the function. So this is what happens, and 1 from the set A it looks like 1 from set A is going to 3 places, is being mapped onto 3 places. So the 1 is being mapped into 3 places, and I told you that an arrow cannot begin, not more than one arrow should begin from one point, because that will mean that this number or this value over here on the left has 3 images, which makes it not a function. So just be careful, this is wrong. Okay, hope you understand this and you can do the problems. Next we will have the 2.1b ready for you.